Thank you. Thank you, Kele. So, yes, my name is Paolo Fasano. I work at TIM. TIM is a major service provider and ICT provider in Italy and Brazil. Recently, my activity was to develop IP and transport automation within the Italian context. And the topic of today really starts a few years ago, more than 10, when we were struggling about the innovation concept of SDN. And at that time, SDN has different declinations, going in different directions as well. There was the emergency of new solutions for automating networking in data centers, such as the Nicira stuff at that time. There was something about disaggregation, hardware and software. There was other ideas going into the service chaining concept in the network. But we followed all of them, more or less, at that time, asking us what could be the most interesting part for a service provider. And trying to answer to this question, we had two kinds of answers. The first one was new services, and the second one was streamlining network operations. So today I will speak about network operations, leaving services for another occasion. Let's say, what about network operations? Main processes of network operations are network creation, where you build the network, delivery of service instances over the network, maintenance, keeping it updated, and assurance, troubleshooting, solving problems, and so on. What was the concept? It was exactly the same that Ron explained well about TMF forum concept of autonomous network and going towards automatic operations everywhere. How to approach that? The point is that you have to act at several layers. In the blue stuff, there are many tools traditionally in telco world managed by IT people. You have several different tools for making network planning, for making customer relationship management, to enable surveillance activities and 24-hour take care of alarms and claims and so on. You have to manage planned activities, so to have an agenda that is clearly known to everybody for the impact it can have on services and so on. You need to manage orders, to make design, technical design on the network, and to communicate among groups, so to have a large communication. That's something that is traditionally done by our IT departments. But every of these activities ends up in the network. And when you are coming to interacting with the network, there is a space in which you need know-how that is both software know-how and network know-how. So that's where we started. We put together a group with me that has both network geeks and software architects and developers, able to focus on that low area of the processes interacting with the network. So starting from that point, we tried to define an architectural concept of what we wanted to reach. Three legs. One is write and the other is read. I have to thank Roque Gagliano that suggested me to use these words, read and write, many years ago, just to say the two directions of the interaction with the network. So configuring the network and extracting all the data that I can get from the network about performance, about operational status, and so on. We had the concept of some brain to these read and write legs in order to be able to make automation in the network interaction and support some of the process I mentioned before let's say, an integrated way. So creation, delivery means not only activate the network element, activate the service, but means also to activate monitoring and get at the same time the source of any data that prove the proper functioning of the node or of the service. While the other stuff is automatic assurance. So once you have a continuous flow of data, use that to find events that could be notified and managed in an automatic way, reconfiguring network. So that was the main concept we addressed. And even at the beginning, we had in mind the idea to follow these architectural choices based on requirements we still believe they are actual and very useful. First of all, don't duplicate functionalities. Don't have in your systems multiple modules doing the same stuff that can get to inconsistent views of what you have on the network. Second, avoid unnecessary interactions with the network. If you have to get information from the network, get it once and make it available to every consumer. Not that every system needs to collect its own data that is another copy of the same data that other systems has already collected. Then we would like to have functional extensibility of the platform we were building and also the ability to work on our own, to develop our own use cases. So that brought to architectural choices that are, first of all, to avoid vertical products doing everything, but not everything, and then you need another vertical product to do something that is not covered by the first. To develop within our platform a single point of communication with the network and make all data available to all modules. To have a modular architecture with clear interfaces between modules and the possibility to integrate among modules, and also to have a programmable platform in which we can develop our own use cases on top of a framework, let's say. So with this principle in mind, we have been doing a long piece of the street with Cisco, because Cisco at that time proved to be among the traditional vendors of this world, one of the most sensitive to this kind of needs, especially because maybe they were integrating several technologies coming from different startups at the moment. We started working with TailF before Cisco bought TailF, We started working with Sedona before Cisco as both Sedona and built HCO. And we met somehow in the interest with the same technologies and the same companies. So at the beginning, what we did, at the beginning, we put together some what we call essential SDN components that on the right part has the NSO as the main block. And we put on top of the NSO a system able to make the workflow manager and also the proper interaction with northbound systems and operators, human operators, with the iTangential. On the read part, we put into the network a few data collectors that are technology-driven, let's say, using all the technologies that are available to read some data from the network. So yes, telemetry and GNMI, but also SNMP, because we had a lot of equipment speaking only SNMP, but also the ability to extract files from the network equipment, because other stuff were only readable through show command directly on the equipment. And on top of those collectors, we decided to have a broker for the data that has the purpose to put all the data available for any consumer. And we developed on top of it some consumers, not every consumer you can have, for initial operations, able to evaluate time series behavior and reporting of worst behaving things in the network. So based on these initial technologies, what we did is to implement a lot of automation use cases covering the four main processes of operations, as I told. So network creation, we did a few use cases of introduction of new nodes into the network for day zero configuration. Delivery is automatic provisioning of new service instances for customers of many kinds. Maintenance, life cycle management, let's say, so day-end configuration, migration and swap from legacy technology to newer technology, reroute of traffic, policy update, software update, in-field testing, and so on. And also some use cases dedicated to assurance for configuration check, connectivity check, service check, and so on, as tools made available to our operators. What we get in terms of benefits? I put here a short list that could be much longer, but I wanted to point out to something that maybe sometimes is not so evident, so immediate. For sure, we get shorter execution times. That means, okay, you spare resources, but means also that sometimes make possible activities that without automation you deem not possible, simply not possible. So some programs become concrete because you have automation. Otherwise, you don't afford them. Another point that was quite important for us was to move into business hours activities that were traditionally performed out of business hours, and leaving in the out of business hours unsupervised activities, so without the people. And that was something that was very useful to make more efficient the network operations. reduced to 0 configuration errors because of standardization, and you reduced the reworking needs to failures that are due to unexpected reasons. Automation sometimes fails, so you need to manage the cases in which automation fails. But if you do automation, also the need to rework things is reduced. And then also the reduction in network inconsistency findings in case of general failure of the network and so on. So the root causes that are in the direction of finding that the network is misconfigured have been significantly reduced. About the monitoring, so we started monitoring what in general is performance data, called performance data, collecting from systems the uptime, CPU, temperature, power absorption, and so on. From interfaces, physical and logical, status, description, traffic, discards, errors, policy violations, and so on. Topology information based on CDP, LDP output, path performance that are from many different technologies. So having traditional IP SLA from Cisco, RPM from Juniper, NQE from Huawei, and other stuff. TWAMP more recently, that everything is implementing. Also some techniques to measure packet loss based on internal patents we did as PNPM and the Y1731. To do what? To do mainly dashboard and reports about network availability, about network quality, about QS policy violations in the network, trunk capacity usage, optical degradation on SFP, trying to anticipate the need to substitute SFPs before having degradation in place, electric power consumption, serial number localization, and many other stuff. But we put together the two legs, the read, the write, and the brain, also implementing some semi-automated closed loop use cases, such as, for example, the management of preventing link saturation in case of live events, football matches, Champions League football matches, something like that, in which you have traffic peaks among the residential that challenges the interfaces of BNGs with the peak traffic. So what we did is to develop systems continuously reading VLAN-based metrics in terms of traffic, number of PPPoE sessions, and so on, making data consolidation, and based on that, automatically calculate, compute an optimized distribution of the VLANs across the interfaces. And then suggest to an operator, okay, you can optimize thing just doing this redistribution of the VLAN and allowing him to check and saying, okay, go, just with a click of the button, automating everything. This is in place since 3-4 years now, continuously used, and I think it gives very good results in terms of quality. We could. So in the platform, I said there are some essential components. We put it at the beginning. Some new components we are introduced later. We have introduced HCO, having the ambition to manage multi-layer topology and path calculations, and way for doing what-if analysis, okay? Following our principle, we asked that introduction was somehow compliant to the fact of not extracting the information multiple times. So HCO needs, for example, to read BGP-LS information and to read SNMP information, but SNMP already collected through our data collectors. So we required an integration to our Kafka bus in order to have this information coming from the collectors already in place. Another stuff is, quite surprisingly, we needed to have secure connectivity between HCO and the PCE that was not available at day 0. It was our requirements now developed by Cisco. And the whole system is also ready for the introduction of segment routing. That is something that is going on into the network. We are extending the number of data we are collecting. So not only performance data, but also syslog, but also routing updates, BGP and IGP. NetFlow and IPFix data. And we are introducing also Accidian based on external probes for doing TWAMP, but every of that information should go through the Kafka in order to be available at the same point of consumption of the information for elaboration. We started also working on data analysis, introducing first machine learning algorithms dedicated to anomaly detection within the traffic. We implemented something like that, that is identifying relevant flows, making some data preparation, clustering, provide the clustering view to human expert analysis that find out which are the real true cases to be analyzed. Starting solving it manually, but when you find that they comes recursively, and there are a lot of cases automating the resolution also. So one of the points we had here is that this process to involve technical people to assess the real problems detected by the anomaly detection systems is an activity that adds complexity and effort to them. So looking for some way to learn from them without bothering the expert at work is something that we are actively pursuing. That's all. So my story starts 10 years ago. This is the experience we have done in trying to put things together in the view of automation. That is what still quite modern today. The path is not finished. It's something that is continuously evolving. And our network is huge and complex. We started not with the new network, but with the brownfield, especially on the monitoring part. It was a very hard thing to do. When we put data collectors, for example, we had to manage more than 100 different technologies in terms of vendors and releases to be managed. But that's done, and we are quite happy about that. I hope that this story can be interesting for you, and if you have any question, I'm here available.